Hi all, welcome to Pantechelearning. Thank you for watching our video. If you like this video, kindly click on the like button and share the video to your friends. Don't forget to subscribe our channel. In this video, we are going to texture segmentation using Gabor filter. So there are many kinds of filters for image enhancements. Apart from that, this Gabor filter rule segment out a particular region of the 2D. Whatever the segmentation which you are going to make it as, create a segmentation layer with the help of this Gabor filter. So inside image processing, Gabor filter nothing but most important filter which completely applied for the texture analysis. So that will be the short answer for this what is Gabor filter. Now inside this Gabor filter, whenever that analysis it is starting, what it is will be taking nothing but the frequency of the respective content. So from that respective content, if an image is specified or it is localized in a particular direction or the region around from various points, so from that we will be able to select the different visions according to their requirement. So this is particularly set as the human visual system. Generally the computer vision asks itself to view like a human, but human cannot segment at all. There is sort of view with the help of their eyes, everything in color. We can view in 3D, approximate distance can be measured, we can recognize the object. So like this kind of categorizations can be done, but segmentation is so through that human visuals should be able to localize that particular area. That localization will be in the form of binary. So for that, this respective filter can be easily applied for the all segmentation purpose. So this is one of the advanced kind of segmentation which is modified by using the Gaussian kernel function, sinusoidal plane wave, and at the same time here we are also using k-means for clustering reasons. So inside this particular appropriate texture representation, we are completely segmenting the data from a 2D image. You see that applications, this particular Gabor filter it is clearly applied from the gray image for gray images to recognize the facial expression, and at the same time we can also use medical conditions, biometric recognition, as well as distinctive between three objects from an image, and also the spatial location also calculated. How that particular workflow will be there for Gabor filter means first you will be providing an input image, and from that the array of Gabor filter should be created. Inside that array only the input image will be taken, and once the filter is taken in the form of array, the magnitude data should be converted into the feature data, and from that finally therefore the classify Gabor feature can be done with the help of the initial requirements inside the display tool from the computer vision. Now therefore let us try with the basic implementation. So as usual, first we have to the image, have to resize it if it is huge, right? And now I am going to resize the same image to that range. Now I am going to convert into the grayscale. After that, state what. So now we have completed with the good part. Now we have to design an array for it. So this array take the then have to create the number of rows. Now we have to apply the wavelength because this is most important part inside the Gabor filter, and how that minimum wavelength and maximum wavelength is calculated means the wavelength of minimum equal to 4 of the square root and the same for max hypotenuse of the respective is taken from the rows plus the columns. Now next thing have to create the floor map. So from the floor map only average value can be obtained. Inside this floor map, the log value of maximum divided by next we have to calculate the wavelength. For that the formula is 2 point condensation of 0:2 that multiplied with the wavelength. Then we have to apply the theta value and orientation value. For that it is the ratio of 0:delta theta. Orientation of delta theta again in the ratio of t minus delta theta. Finally we are applying our wavelength of the orientation, where combination will be finalized as of an operator or is nothing the image, and therefore I have applied it. So from this I have to take the Gabor magnitude value. So for that for image we have to apply for all the image Gabor value. Array has been. Next part is questions 2 to feature. For that thing, have to according to the image has. For that, we'll be applying the for loop of the Gabor. Here we have to press the values. Therefore, the Gabor applied from the Gaussian filter. Now, from the we are applying the Gabor range. So the next part, we have to create the columns for here. Axis there. So here the data will be taken for x and plus for the x value we are setting. Initially, dimension that we have to calculate the magnitude for x axis. Same thing definition there dimension, but from the data. In this way, we will be converting to the Gabor from. Along with the feature set, we have to add the respective points of tracking. For that, we have to calculate the matrix. Now we have to get the data. Also according to the x, much columns and that base. Now we have to take that zero mean value. For the it takes the mean. First average value will be taken. Same thing dividing we can. Now we have to calculate the coefficient. For the coefficient, we are applying the principal component. From that, we will be able to collect the from this particular coefficient directly. Again, we have to display that. Therefore, now after that, we have to classify particular cluster whatever the features which has been obtained. We need some algorithm. So the best algorithm to group data on k-means only, which is an unsupervised algorithm. So now for k-means algorithm, see the function data will be because of time. Clusters can be changed depending upon as required. Then we have the data. From the tree shaping, same size many able to put form. These data and all comes for the array government. For us, it is according to our view that the filtering is be clear. This feature is applicable to the color images. Different. Here I am just showing with the resize and without resize how much quick it be able to provide the response with the variation. Therefore, the segmentation has clearly obtained. Wherever the white or the particular highlighted part which is able to see for us, that portion only has been segmented over here. So the red fort image, how that segmentation, putting the fat and the top, everything we are able to see. So this particular process takes, depending upon the size of the image and the configuration of the took more than 100 over here. In this way only able to segment using Gabor filter. Texture subtraction or texture segmentation using Gabor filter with the help of computer MATLAB. Thank you for watching our video. If you like this video, kindly click on the like button and share the video to your friends. Don't forget to subscribe our channel. Thank you for watching our video. If you like this video, kindly click on the like button and share the video to your friends. Don't forget to subscribe our channel.